We've seen examples of how to convert fractions into decimals, but we should spend a minute to think about, can we always do this? The last examples we did required us to multiply either factors of 5 or factors of 2 to create tens in the denominator. If there is a factor in the denominator that is not a 5, that is not a 2, and that cannot be reduced with the numerator, then we actually can't rewrite the fraction as a terminating decimal. That will help us decide, just by looking at a fraction and thinking about its factors, if the fraction can be written as a terminating decimal. Terminating decimals are the ones where you have a fixed number of digits and it's over. Like 1/4 turns into 0.25. Sure, you could tack on zeros after the 5, but zeros don't represent value when they go that far to the right. The opposite of a terminating decimal is something like 1/3. We know that 1/3 does not have a factor of 2 or 5 in the denominator. In fact, 1/3 turns into the decimal 0.333333333. Okay, it keeps going. It never stops. We call this a repeating decimal. That's the opposite of a terminating decimal. And sometimes we use the notation 0.3 with a bar over it. Now for now, we're just going to talk about terminating decimals. We will talk about repeating decimals later. But know that there are two types of decimals: the ones that terminate and the ones that do not. We're going to talk about the ones that terminate and how to identify which fractions can be written as terminating decimals. We're going to start by looking at each fraction and factoring it completely. Our numerator is 7, that's prime, so it can't be factored any further than just 7 times 1, so we'll leave it as a 7. 8, however, that can be written as 2 cubed. Now looking at the denominator, I only have factors of 2. Those are fine, because we can multiply by matching factors of 5 on top and bottom, so that we can create a 10 in the denominator. If, however, we had a factor other than 2 or 5, we would have some problems. We wouldn't be able to multiply those denominators up to make a product of 10. For example, 1/3. It doesn't matter if I multiply top and bottom by 2, or if I had multiplied top and bottom by 5, there is no way for me to turn the 3 into a 10. So those fractions are not terminating decimals because they have factors that are not 2, that are not 5 in the denominator. Let's take a look at another one. We have 11 over 250. We're going to factor the denominator. 25 times 10 is 250, and 25 is 5 squared. So we have 5 squared times 10. 10 is 2 times 5. So our denominator is actually 5 cubed times 2, which is perfectly fine. We only have two different prime numbers in the denominator. We have a 2 and we have a 5. And as long as we can multiply the appropriate number of 2's or 5's to make 10, we're fine. We have 3 factors of 5, only 1 factor of 2, so it looks like we're going to need 2 more 2's. So that we can have 5 cubed times 2 cubed, which ultimately gives us 10 cubed, and on top we have 11 times 4, or we have 44. So as long as we can turn our fraction into an equivalent fraction with a denominator that is 10 raised to whatever power you want, then yeah, we can write it as a terminating decimal. But if we get a situation where there's a factor that is not 5, that is not 2, that's when we have a problem. For example, part C, we have 21, which is 7 times 3, over 28. 28 is 7 times 4. Now in this case, let's turn the 4 into a 2 squared. In this case, I have factors of 2, fine, but I also have a factor of 7. 7 gives us a problem because we can't multiply 7 to a number, a whole number, and make 10. Doesn't work. However, in this case, this 7 is not a problem because when we factored our numerator, we also found a 7, which means those two factors divide off. We're left with 3 in the numerator over 2 squared in the denominator. We just need to multiply by 5 squared on top and bottom so that we can have 10 squared in the denominator, and we would have 75 in the numerator. So as soon as we find that our denominator can be multiplied up to be a power of 10, we know that it can be written as a terminating decimal. We've got one left here. We have 37 over 768. If we factor the denominator, 768, it becomes 2 to the 8th power times 3. 37 is actually prime, so we'll leave it there. Now, here is the problem. We have a 3 in the denominator. And because 37 is prime, I know that it will not reduce with 3, and it will not reduce with 2, which means the 3 in this denominator is going to cause a non-terminating decimal, the same way that the 3 in the denominator of 1/3 creates a non-terminating decimal. So we know part D cannot be written as a terminating decimal. And in short, the way that we figured that out was by factoring the numerator and denominator completely, simplifying the fraction as far as we can, and then looking to see if there are any prime factors that are not a 2 and are not a 5. 2 and 5 are fine. You can have only 2s, you can have only 5, you can have a combination of 2s and 5s, but nobody else. The last thing to talk about in this section is how to order these terminating decimals. 2 terminating decimals can be ordered simply by converting each to a rational number and then plotting those rational numbers on a number line. For example, if we're looking at fractions like 55, a decimal like 0.55, we can think of that as a fraction, 55 over 100, and we can compare that to other fractions, like maybe we look at the decimal 0.02. That turns into 2 over 100. We can see that the further to the right these numbers are, the bigger they are. The further to the left these numbers are, the smaller they are. So if we wanted to order decimals, we can turn them into fractions and put them on number lines. We've already learned how to draw fractions on number lines. Or we can notice that these decimals are special fractions in the sense that we can find a common denominator very, very easily. So converting to a rational number should be a piece of cake. 0.02, the 2 is in the hundredths place, which means the fraction is a denominator of 100. And the decimal digits go up top. 0.55, the last digit of my decimal, my terminating decimal, is in the hundreds place, so the denominator would be 100. And then I copy my decimal digits on top. Now, because these all have the same types of denominators, powers of 10, we can skip converting to a rational number and just look at the digits, because notice once these are fractions, we're really just comparing the numerator. And if the numerator is really just the digits to the right of the decimal, then all we have to do is compare digits to the right of the decimal. To compare two decimal numbers, terminating decimals that is, we'll line up the place values and start from the decimal, moving towards the right. Look for the first digit that's different in the two numbers. Whoever has the bigger digit in that differing place value wins. So if we're looking at 0.3450 and 0.1474, I can see that the very first differing digit is actually in the tens place. 3 is bigger than 1, so that is the bigger number. But if I had something like 0.3450 and 0.3451 or 0.3449, in this case, comparing which one is biggest and smallest, the tens place digits are all the same, so we'll ignore those. Hundredths place digits are all the same, we'll ignore those. In the first two decimal numbers, the thousandths place both has a 5, but this third one has a 4. So I can tell that these two are bigger than the third number. So that third number has to be the smallest. Now I need to decide between the two bigger decimals which one is the biggest. If they both have 5 in the thousandths place, then I need to move over to the 10,000ths place. And here I notice there's a 0 in one decimal number, there's a 1 in the other. 1 is bigger than 0, so this one has to be the biggest. And then that means the other guy is the middle number or the medium number. So if we wanted to order these, we could say 0.3449 is less than 0.3450, which is less than the biggest number, 0.3451.